This conference will now be recorded.
Hi, and welcome to Aspire Test Prep's web lesson on absolute value parameters. Aspire Test Prep offers online one-on-one SAT and ACT instruction, world-class instruction, and we also appreciate your support on Patreon to support our efforts to bring blue chip tutoring to anyone who has ears to listen. Let's go ahead and get started with our lesson on absolute value parameters. The SAT is all about these code words and references. And if you see those code words and references and know what they mean and how to use them, you'll do better than everyone else. So the main idea of this little concept here, absolute value parameters, is that you've got a situation with absolute value, like absolute value of x plus 7 equals 2. And without being prepared for it, it would mean nothing, of course. But before we start with that, I'll sort of give you a comparison to that idea. Let's say that I had the number 5, right? And that number is right in between 3 and 7. So now you know I'm talking about the number 5. So now I'm going to call it x. It's the number that's squarely between 3 and 7. So let's see that on a number line. I've got 3 and I've got 7, and I've got this kind of range here in between, and 5 is the center number there. So we're kind of talking about the number 5, but what we're really talking about is that space in between 3 and 7, of which 5 is the center of it. So one way to express this range is right here, a nice little inequality. My number is less than 7 and greater than 3. But another fancier way to express this is to say that the distance between any number and 5 is less than, in this situation, the distance between any number and 5 would be less than 2. So just imagine this. Just imagine if I were programming a computer to throw darts at this line and I wanted it to fall within the yellow area. I would say, okay, well, don't be any further away than 2 from the number 5. So why is the number 2 a bad number here? Because it's 3 away from 5. Why is the number 1 a bad number here? Because it's 4 away from 5. But the number 3, it's exactly 2 away from 5. And the number 4 is 1 away from 5. Same thing on the other side. This is 1 away from 5, so it's okay. This is 2 away from 5, so it's kind of on the limit. This is 3 away from 5, so it's too far away. 4 away from 5, and we're really too far away, right? So the distance between any number and 5 needs to be less than 2 in order to fall within the yellow region. So a way to express that would be the distance between any number and 5. So that absolute value expression there is a fancy way to say the distance between any number and 5. Because let's say we're talking about the number 6. Well, 6 minus 5 is 1, right? So no need for the absolute value there. 6 minus 5 just is 1. But if I was talking about the number 4, the absolute value of 4 minus 5, well, that 4 minus 5 is negative 1, and now we're seeing why we need the absolute value. Because absolute value, and for people who don't know what that means, that's these purple bars here, right? Absolute value would take a negative number and turn it into a positive, and if it's already positive, it would leave it the same. So the absolute value of negative 1 is 1. But if I had the absolute value of positive 1, it would also be 1. So the expression for the distance between any number and 5, that's this whole thing right here. It's the absolute value of the difference between them. Could I have put the 5 first? Yeah, I could say the absolute value of 5 minus x and it would mean the same thing. Because that's what absolute value does. Because it's turning it positive, it doesn't matter which one comes first. But in any case, that's the distance between any number and 5 in pink. And that distance must be less than 2. So kind of a funky, weird idea, but it gets a little easier every time we try to apply it. So let's look at this problem here. 2 different points are 7 away from 2. In the example I gave you, it was a distance that was 7 or less than 7. But here, I've got the number 2, and then I've got the 2 points that are 7 away. So 7 to the right would be the number 9, 7 to the left would be -5. So if we wanted this yellow region, that would be a distance that's less than 7 away, or less than or maybe less than or equal to. But in this situation, we're talking about the two numbers that are exactly 7 away, -5 and 9, right? So the, okay, computer issue here. Okay, so the distance between any number and 2 is exactly 7, because the two numbers that are 7 away are -5 and 9. So the distance between any number and 2, that's x minus 2, absolute value, and that exactly equals 7. So here we are, nice and easy. Let's take a look at this next problem. Now, a nice way to take advantage of these videos is whenever we go to a new problem, just go ahead and pause your screen and see if you can solve the problem on your own. Then, of course, go ahead and listen to the solution, watch the solution, and see if you got it right. So here we have two numbers that are 2 away from 8. So I've got the number 8, 2 to the right, 2 to the left. So we're talking about only these two numbers. So we're saying the distance between any number and 8. So I've got the 8 here, and any number is whatever number we're talking about, right? So the distance between any number and 8 must be exactly 2. And what we're saying right there is the only two numbers that fulfill that are 6 and 10. So the distance between any number and 8, this is the expression for the distance between any number and 8. Like I said before, it could be this, but you know, the convention in this situation, the usual thing is to put the variable first. So the distance between any number and 8 is exactly equal to 2. So that's this right here. Okay, so here's our next problem. We've got a number line, and we've got the point -10, and we're going 4 in each direction. So 4 to the right would be -6, 4 to the left would be -14. The distance between any number and -10. So the distance, once again, between any two numbers, one way to express the distance between two numbers on a number line is to subtract those two numbers and take the absolute value of that difference, of that subtraction. So that's what we did. We have x and -10. We subtracted them and took the absolute value of that. And that distance is equal to 4. So we're talking about -10 as the central number, and these two green numbers as the two numbers on the outside. So you'd have the double negative right here, which turns into a positive. Quick side note here. So by the way, the answer would be C. So quick side note to this situation. If I gave you a problem, if the SAT gave you a problem that started at this yellow point and basically said solve it, what would you do? Well, you should have it as an instinct to go ahead and say x plus 10 equals 4. So we've got one situation where we just go ahead and take away the absolute value, and x plus 10 equals -4. And then you solve them both. And what two answers are we going to get? Take away 10 from both sides, -6. Take away 10 from both sides, -14. So surprise, surprise, the exact two numbers that we originally had here. So we kind of checked our answer by showing this example here. But now, why does absolute value have these two scenarios when you're solving it? Because let's say I gave you the absolute value of 5. Well, absolute value, if it's positive, it leaves it alone, so it's 5. Or if I gave you the absolute value of -5, absolute value, if a number is negative, it turns it positive. So what I'm saying here is, if you have an answer of 5, you don't really know if the thing that created that answer was originally a positive number or a negative number. So if you're working backwards, there's just no way to know. So in this yellow example here, we're telling you that the answer is 4. So we have no way of knowing if the thing inside of this absolute value here was originally positive or negative, and that's why we had to go ahead and play the positive situation and the negative. So moral of the story there is, whenever you have an absolute value problem on the SAT, something that looks like this originally, then you just go ahead and you play the positive scenario and the negative. And that's something that we'll probably cover in future videos. Next problem. 2 points are 5 away from negative 13. So we've got negative 13 here. 5 this way will take us to negative 8. 5 this way will take us to negative 18. And so the distance between any number and negative 13, x minus negative 13, absolute value. So that's the expression for the distance between any number and negative 13, and that's equal to 5, because that distance is going to be 5. So now that double negative right here becomes a positive, so it's absolute value of x plus 13 equals 5. Looking at number 5 now. Now it gets a little more complicated. So, absolute value parameters is a reference to an idea. When you see a problem like this, if you remember this lesson, you'll know how to do it. What's a test like the SAT going to do? They're going to make it more confusing by using problems that are heavy on variables. So there are no numbers here. It's heavily theoretical. You really have to know what you're doing to get it. But since we have such a good foundation, it shouldn't be so bad. So we have two numbers that are A away from a point with a coordinate B. So B is my number. Then I've got the number that's A in this direction and the number that's A in this direction. So those two distances that have the arrows are a distance of A. I could call them B plus A and B minus A. But I'm not even going to get into that. I'm just going to create the little image here so you have a mental image of what we're talking about. But what are we saying? We have the distance between any number and B, absolute value of that distance. So notice that whether it's B or some number that we know, it's the same idea. It's the distance between any number and B. Subtract the two and take an absolute value. And that distance is equal to A because it's A away. So without having to really be complicated and call this, B plus A and B minus A, without having to get into all that, we already have our answer. Going to our next problem. Now we're talking about a range because we're not talking about numbers that are exactly a certain number away from the center number. We're talking about a range, numbers that are between 68 and 82. So this is a little more like our original explanation here. But let's just go ahead and imagine what this looks like. So we've got 68, 82, and some number in the middle. So what's the number that's exactly between 68 and 82? It would be the average of 68 and 82, which is what you would get by adding the two numbers and getting 150 and dividing by 2. So we averaged the two numbers and it came out to 75. So we're talking about this range in yellow with 75 as kind of our anchor. So like we said earlier, one way to describe this range is x is a number between 68 and 82. Like that, right? That's the more common way to do it. But what we're going to do is we're going to just go ahead and do the absolute value inequality way of doing it, which is to say 75 is our middle number. The distance between any number and 75, that right there is the expression for the distance between any number and 75. That distance must be less than or equal to, if we want to be specific, 7. So that's this right here. So the distance between any number and 75 must be less than 7. Looking at the next problem here. So a height is between 54 and 66. So what's the middle number? It's the average of 54 and 66. It's what you would get by adding them and then dividing by 2. Dividing by 2, and you get 60. So we're talking about this range with 60 as our middle number. So we're saying the distance between any number and 60, absolute value of that distance, must be less than how much? So what is the distance between 60 and any number at the end? Well, this is a distance of 6 here, and that's a distance of 6. So the distance between any number and 60 must be less than 6 in order to have that little pink range there. So that's this answer right here. So right here, same idea. The scores, now scores must range between 0 and 170. I would call that unnecessary decoy information, which the SAT is really good at giving us. 132 to 175 is what they tell us. So we want to know the middle number, so we're going to average 132 and 175 by adding them up and dividing by 2. And we get 153.5 right there. So now we know that we're talking about this range right here, the numbers that go from 132 to 175. And the anchor, the middle point, is 153.5. So one way to paint this out is to say, okay, well, how far away are these two? We get that by subtracting 153.5 minus 132. Tells us this is a distance of 21.5. And it's the same thing if we did 175 minus 153.5, we'd get 21.5. So what are we saying? The distance between any number and 153.5 that distance must be less than 21.5. So now we're looking at this number 9 here. And now once again, what does the SAT do if they want to make a question seem more difficult? They just use a lot of variables instead of numbers. So we're saying that we've got the people who actually show up, which is C. And then we've got these two numbers that are, it's off by B, is what the problem says. So this distance and that distance is B. So this question is a little different than everything we've been doing before because we've been just loosely using the variable x. But the estimate in this problem is A. So before we were saying the distance between any number and C, but here the any number is the estimate, it's the A. So we're talking about the distance between the estimate and the actual number. So this is the distance between the estimated number and the actual number, absolute value of that distance, and that distance must be less than B. Now, this is not one of the answers, but we actually talked already about why. We said that when we're finding the distance between two numbers on a number line, we're subtracting them and taking the absolute value. But kind of like the purpose of the absolute value is that it doesn't matter in what order you subtract. So saying absolute value of A minus C is actually mathematically equivalent to saying absolute value of C minus A. So since our red answer wasn't in the answers, we're going to go ahead and see it this blue way. So it still doesn't quite look like the answers. But earlier we said that if you had an absolute value, something like this, the instinct needs to be to leave it alone and solve that, and to set it equal to the negative version of the number. And we solve that by taking away 2 from both sides, so we get that, right? So if you have an absolute value, you're going to go ahead and set it equal, leave it alone, and set it equal to the negative, and get your 2 answers, right? So if you have an absolute value inequality, it's a step further. Let me actually arrange this a little bit better. So we said that we were going to just solve by breaking this into this side or this side, right? Just leaving it alone and setting it equal to the negative. So if we had something that was an absolute value inequality, like we have here, C minus A less than B, we're going to do the same thing. We're going to say C minus A and B right here, C minus A and negative B. So same thing we just did a second ago with the x plus 2 equals 5. But on the first one, we're going to leave it alone, just like we did a second ago. And on the one that's negative, on that one, you reverse the inequality. So you have your two scenarios, but when it's an inequality, there's an extra step. On the negative side, you reverse the inequality symbol. Now, why is that? Because when you're dealing with inequalities, when you're solving them, when you multiply or divide by a negative number, you reverse the inequality. And that's a nice rule to keep in mind. So when you're doing algebraic steps on something that's an inequality, not an equation, what's the number one way to mess up? By forgetting that if you multiply or divide by a negative, you reverse the inequality, like we did right here. We turned it from less than to greater than because we were using the negative. So in essence, we were multiplying by -1. So here we've got C minus A less than B, C minus A greater than -B. So if we kind of put this all together, we've got C minus A, it's less than B, it's greater than -B. And that's kind of like this answer. This answer here is basically just saying, well, we're not going to really take it as far as -B because that's pointless. We're just going to take it to 0 on the left side. And it's one of the ways that a problem could look more difficult if they chose to sort of say 0 in the beginning. It's just one little wrinkle that can kind of complicate the problem, which is, you know, pretty much what the test writers would want to do. Make something just a tiny bit more complicated to confuse just a few more people. And that's why we prepare. And hopefully that's why you'll always be watching our videos so you can be ready for anything that can possibly come up on the SAT. All right, so looking at number 10, we've got the distance between any number and the target P. That distance must be less than 5. But what's the any number here? It's the Q. The distance between what she actually writes and what she was targeted to write has to be less than 5. So like I said before, if Q minus P wasn't in the answer choices, I would look for P minus Q because absolute value of Q minus P, absolute value of P minus Q, those are interchangeable. So now to solve this, we would say Q minus P is less than 5, Q minus P is greater than -5. Now putting that all together, you still have the Q minus P, but you've got it less than 5, greater than -5, and that is exactly this answer. So just like on question number 9, if we had a 0 right here, that would kind of be the same thing. You wouldn't be offered both, but you'd be offered one of those two statements as an answer. Okay, on this question here, we have a temperature that needs to be within X of 25. So 25 is the central anchor point, and we're going X this way, and we're going a distance of X in this direction as well to two other points. So the temperature actually is Y. So the distance between any number Y and 25, that distance must be less than X in order to fall within this range. So that's this answer right here when you solve it out, because let's go ahead and do that here. Because when you have an absolute value inequality, you're going to do one answer where you just leave it the way it is and get rid of the inequality, and one answer where you reverse the inequality and multiply by -1. So I've got my Y minus 25 in the middle. I have it less than X and greater than -X. Or we could say, you know, they might give me that, or they might just put a 0 on this side. And which answer does this match? It matches A, like we said from the beginning. Okay. So during his regimen, a boxer wants to stay sharp, but not so much as to cause fatigue. He aims to throw A punches, but ends up throwing B. So the distance between A and B, he needs to be within C of his intended number. So I might say A minus B or B minus A. Quickly glancing at the answer choices, this question is saying B minus A. So same difference. Absolute value of B minus A less than C. Solve it out, you get B minus A less than C, leave it alone, and B minus A greater than -C. Reverse the inequality and multiply by -1. So you have your two scenarios, your two ways to work out an inequality, an absolute value inequality. And now putting it back together, that means that B minus A was less than C, but it was also greater than negative C. And that exactly matches choice D. And that'll be it for this worksheet. It's a very intense, relatively intense math topic for the SAT, but we hope you enjoyed it. If you have any questions, you can leave those in the comments section. And as we said, Aspire Test Prep offers one-on-one online SAT tutoring, and we also appreciate your efforts to support our free videos on YouTube using Patreon. Thanks so much for watching our video.